Random access memory. RAM is a crucial component in a computer that plays a vital role in its overall performance. RAM acts as a temporary working memory for the computer, allowing it to quickly access and store data that is actively being used by the CPU and other components. Let's take a look at how RAM works. RAM stores data in electronic cells, organized in a grid of rows and columns. Each cell can hold a binary digit, 0 or 1, and they are grouped together to store larger pieces of data, such as numbers, text, and program instructions. When the CPU needs to access or modify data, it sends requests to the RAM to retrieve or update the information. Unlike storage drives, which store data on physical disks, RAM is purely electronic and offers much faster access times. The CPU can read and write to RAM much more quickly than it can to storage drives. RAM is volatile memory, meaning it loses its stored data when the computer is powered off or restarted. This is in contrast to non-volatile storage like hard drives or SSDs, which retain data even when the power is turned off. Operating systems use a portion of the hard drive as virtual memory to supplement physical RAM. When the physical RAM is full, the operating system moves less used data from RAM to the hard drive, and vice versa, to keep the most actively used data in faster RAM. Modern CPUs have multiple levels of cache memory that act as intermediate layers between the CPU and RAM. L1, L2, and sometimes L3 caches are much faster but smaller than RAM. They store frequently used instructions and data for quicker access. RAM speed is measured in megahertz or gigahertz and affects how quickly data can be read from or written to RAM. RAM capacity determines how much data can be stored and accessed simultaneously. More RAM allows for smoother multitasking and better performance with resource-intensive applications. Some motherboards support dual-channel or quad-channel memory configurations, allowing data to be read from and written to with 2 or 4 RAM modules simultaneously. This can improve memory bandwidth. RAM plays a significant role in overall system performance, especially during multitasking, gaming, video editing, and other memory-intensive tasks. Having enough RAM prevents slowdowns when switching between applications and enables smoother gameplay. To summarize, RAM provides the CPU with fast and temporary access to data, allowing the computer to perform tasks efficiently. Just remember, when selecting RAM for your PC, consider the capacity, speed, and compatibility with your motherboard and CPU. More RAM and higher speeds generally lead to better performance, but the specific needs depend on the tasks you'll be performing on your computer. This concludes Lesson 5. Please continue to the next lesson, and thanks for watching.